The other thing is, I mean, this is more procedural, but I do like to get a that second test in before the withdrawal deadline because it has happened in the past where, and it's kind of a sad state of affairs. Person thought that they would be doing all right. Withdrawal deadline comes and goes. They don't withdraw from the course. Then they take the second test and bomb it royally, and now they're pretty much done for the course, and now they don't have an out. You know, so I don't want to rob you of that opportunity. It doesn't happen often, but when it does, it's pretty sad. Expected value. Uh, Another name for finding the mean of a probability distribution. So kind of like what we just did. We use expected values when dealing with potential gain or loss in capital. So money, typically. In the New York State daily number, your goal is to select the same three-digit number that the computer selects. For straight play, and that's what we'll worry about here, the payout for a $1 bet is $500 for the winning three-digit number. Determine the expected value for this game, and what does it mean? Okay. So, with expected value problems, we deal with basically wins and losses. All right. So the X value would represent what you stand to win or lose. Okay? So, and it depends on the rules for the game. What we're going to do is we're going to assume that if you win $500. If you lose $1. All right? So we're going to assume you get your wager back. If you win. That's not always true. Right? In a lot of cases it's true. It's true frequently enough that it's worth making that assumption. But this is actually the foundation of how things like insurance premiums are developed. So when they determine how much you pay on a monthly basis for your life insurance policy, they're actually using this concept. It's a more advanced version of it. This is where it starts, though. And so, in that case, you don't get your wager back. The wager that you're paying is the monthly payment, the monthly premium. So if you pay $200 a month or $50 a month, depending on your health, then you're losing all that money. If you win, quote unquote win, then you get a lot of money. Well, you don't. Your family does because you're dead. But that is the case of winning. But you're paying into it, and you have to assume that there's some kind of interaction. That premium is going towards something that in turn is allowing them to pay you that money to begin with, right? So those insurance companies are gambling as part of their business. So the same thing with car insurance. So they determine a price based on your driving ability, and that's how much you pay. But what they do is they use the money that everybody pays, and they invest that to make more money, right? But in general, if you really break it down to its basic components, they're using the money of the people who are good drivers to pay for all the accidents, right? Because the people who are good drivers should outnumber the number of accidents that happen, all right? The bad drivers who don't get into accidents have to pay more, right? Because you get speeding tickets or maybe minor fender benders and things like that, but they have to pay more in their premium. So the good drivers pay less, the bad drivers pay more, but all of that is to pay for the accidents. So if you have policies for, let's say, 10 million people, in theory, you're only paying out for, let's say, 10,000 accidents, right? That's the same idea here. When how can it be possible that you only wager $1 in a lottery and you could somehow win 500? That's because they're collecting all the money for the people who lose, the lottery and then use that to pay the winners, right? So when you see that the jackpot's gone up to like $10 gazillion, just think about how many people have had to lose the lottery in order for that to build up to that amount. That's a lot of money, right? So then the probabilities that go along with this, right? So it's a 3-digit number. Let me think about how many 3-digit numbers there are. Well, here's one. Here's another. There's 1,000 in total. Because you could go from 000, that's one number, then 001, 002, 003, all the way up to 999. All right. You could also look at it as, you could say 1 in 10 chance of selecting the first number, 1 in 10 chance of selecting the second number, 1 in 10 chance of selecting the third number, in which case you get 1 out of 1,000. Either way, you have a 1 in 1,000 chance of selecting the correct number. All right. In lotteries, order matters. So if I select, or in this particular type of lottery anyway, if I select 891 and 198 comes up, I don't win, or at least I don't win this way. They have an option to box your number, which means that whatever number you select, if it comes in any order, you still win, but they pay out less for that. Then you have numbers like, let's say, 999 or 333. Those are automatically boxed numbers because it doesn't matter what order the threes come up, you're still going to win. So those pay out less. So if you want to win the maximum, you don't want to choose something that is a repeat. All right. Now, if there's a 1 in 1,000 chance of winning, there's a 999 out of 1,000 chance of losing. All right. So for expected values, again, because it's the same as finding the mean of a probability distribution, you could put it in your calculator, L1, L2. But in this case, the calculations are so easy that it's worth just doing it by hand. Because all you're doing is multiplying across. You get 500 over 1,000. You get 999, negative 999 over 1,000. And then what we do is we add the numbers together. So that gives us negative 499 over 1,000, which goes to decimal form as negative 0.499. All right. So the negative symbol tells us that the game is not to your advantage. All right, it means your expected value is at a loss. That 0.499 is the weird part of it, because that's saying on average you can expect to lose 49.9 cents for every dollar spent. On average, you can expect to lose, that's the negative sign, 49.9 cents for every $1, I'll say wagered instead of spent. Because spent often implies you're getting something for your investment. In this case, not often. All right. So it has to do with this number here. Now, that's not saying that you're losing or basically 50 cents every time you put a dollar down. It's saying that if you were to play this game over and over and over again, and all of your friends were to play this game over and over and over again, and everybody else were to play the game over and over and over again, if you add up all the credits and debits, subtract the two, you're going to be looking at an average result, and divide by the number of people who actually wagered. You're looking at an average of about 50-cent loss on each dollar bet. So what that means is that the game is to the advantage of the house, which would be the government or whoever's running the lottery, and to the disadvantage of the individuals. Right? And the same thing with casino games. It actually turns out, and well, just based on this one, the daily number is an easy one. You know, it's like you just pick 3 numbers. First ball up is this, the second one is that, and the last is that. And you either win or lose. It's very easy to justify playing that game. But you're probably not going to win very often. You could spend a lot of money on it, especially if you get more than one ticket every day. It's called a daily number, so that means that it happens every day. And its expected value is terrible, right? The expected value for, let's say, the game of roulette is actually negative 0.027. So about 3 cents for every dollar bet. This is 50 cents for every dollar bet. You're actually better off playing roulette in the long run. The issue is roulette doesn't pay off the same way a lottery does in the short run, right? So all I have to do is win the lottery once, depending on the kind of lottery it is, and I'm good. I don't have to play it again after that. You know, if I win the big one, then I'm done. I never have to play a lottery again. So in the short term, those mega whatever lotteries are really worth it. But if you're consistently playing over a long period of time, then the casino games end up being a little bit better, right? Neither of them will ever be to your advantage, so they're never a good idea, but some are better ideas than others, right? We're going to actually table going over roulette because I have a little mini project that we're going to do. It's just I don't want to take too much time to deal with it right now. So we'll skip. It's not something that we're going to cross out. It's not a typo, but we're just not going to do it right now.